Really is about preparing kids in a much more broader fashion.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here live at Longfellow Elementary School, home of the Lancers, and today we're all here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Tracy. And if you want to get a hold of us here, we're at Bakersfield, 636-4357. You can get us at San Luis Obispo, toll free, 1-866-836-6284. We have email, dothemath@kern.org. You can watch us online at dothemathonline.net.
All right, don't forget, we've also got a lot of things on social media and things like that, so keep an eye out for those things. We have a very special guest in studio, and we also have a couple of things going on today. Today and tomorrow are the final 2 days for the 5th grade call-in contest. At the moment, we have 4 schools that are tied. So 4 schools that are tied for the 5th grade call-in contest. So you've got today and tomorrow to finalize that with the 5th grade call-in contest. Also, this week and next week, all 4 days, any student that calls and gets on Do the Math, we will be sending you tickets to Holiday Lights at Com, a wonderful experience, and they've been doing this for a long time. I mean, it seems like years and years and years. I mean, it's got to be at least a decade that they've been doing this thing. I'm not even sure. You know what? That's what we need to talk about somebody tomorrow, because we'll be out at Com tomorrow to find out how long the Holiday Lights at Com has been going on. I know that they've been great supporters of Do the Math, and we always look forward to going out there, learning a little bit more about the different animals that are out there, and obviously the lights and how they change them up a little bit every year, but always a great time for a lot of families. Well, before we get to all of the other math, let's first take a look at today's Math in the News. All right, so Thanksgiving just got through, and you said you did a lot of eating.
Yeah.
As we all did, I'm sure everybody did. Now, another thing that happens right after Thanksgiving, what is that? I mean, you guys
go to the gym, diets.
So some people do that, go to the gym and start dieting.
Yeah.
Other people will do what, especially the night of Thanksgiving or the next day?
Sleep? No.
Yeah, well, that's what I would be going for, but stores.
Oh, Black
all the
Friday.
sales, Black Friday, right?
Got
Seems like it's Black Thursday night now, Black Thursday afternoon, and things like that. But anyway, so the holiday shopping season, I guess, is upon us now. So I found an article, and here we can see that there's a photograph of just a couple of boxes, plain brown boxes, right? Which people are going to need to send items off to various parts of the country and different parts of the state or wherever they're at to send people their goods. Well, there's another reason that this was in the news. Relief packages for refugees or those in disaster-stricken areas meet essential needs containing food and medicine. So you never know what's in the box. But along with the essentials, there's never enough room for toys for kids. All right? So playing helps them to cope when they're in these disaster-stricken areas. And it's called the Inside the Box. So somebody created this, and that's the way they look on the outside, but then inside,
very cool.
and things. This is the way they look. So this was designed by Lisanne Koning. So they contain food, water, toiletries, and other goods when people are displaced from their homes. But it also incorporates games right on the box.
Very nice.
So what they do is they take that, and it was in a design academy in the Netherlands where they developed this and eventually got it out and useful. But you can see where they can cut out the things out of the cardboard and then make different games and things for the kids to play with right out of the box, which is inside the box, in order for the kids to, so I thought that was a pretty cool idea.
Those are cool.
As people get ready for using boxes to ship out their holiday items. So I figured, all right, let's take a look at surface area of boxes, and this one right now, surface area of a prism. So we're looking at the top, the front, the left, and I do believe, were you on last week when we were doing the one with the file cabinet?
The sticky notes?
And how many sticky notes it'll take to cover that. But anyway, surface area is something that the kids are learning, and typically around, I would imagine, 4th, 5th, 6th grade is when they're learning surface area for the first time. And we can see that you've got the height of the prism, the width, and the length. And with all of those, we can see an example here. If we have this measured in centimeters, we can see that the length is 3 centimeters, the width is 2, and the height is 5. So you're going to go length times width, width times height, length times height, multiply that all by 2. And we can see when you put the numbers in to substitute for the variables, how that all comes out to be the surface area of 62 square centimeters. And that, along with the box, inside and out, is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available almost Tuesdays and Wednesdays throughout the regular school year. And just a reminder, if you're just tuning in, all students that phone in this week and next week will automatically receive themselves a ticket to Holiday Lights at Com. We also have an opportunity for students to win themselves tickets to any athletic event at CSUB, courtesy of our friends at Cal State University Bakersfield Athletic Department, so we appreciate those guys for that. A lot of great things going on. The 5th grade call-in contest is going on right now, and we have a 5th grader in studio. Luke, how are you?
Good.
Why don't you let everybody know where you go to school and what grade you're in? Even though I already told them what grade you're in, but...
I'm in, I go to Stockdale Elementary, and I'm in 5th grade.
And how is 5th grade?
It's good.
Okay. First thing I want to do, I don't want to put you on the spot. Have you guys heard about the 5th grade calling contest in your classroom?
No.
No. All right. So who's your teacher?
Miss Martinez.
All right. So what we're going to do is we're going to send a little thing out to Ms. Martinez tomorrow and make sure she finds out. I'm only kidding, because you know what? I bet you if you go, hey, Ms. Martinez, are you aware of this 5th grade calling contest? She probably is going to go, oh yeah, there's something up on the wall right there probably. So check with her tomorrow and see if she's aware of it.
Okay.
All right. So 5th grade. How's it going so far?
Good.
Yeah? What do you like best about 5th grade?
Probably STEAM.
So STEAM.
Yeah.
So what kinds of things are you guys doing with that? Can you,
Science, technology.
So does anything come to mind that you like about it?
It's kind of like hands-on, so you get to, it's not like in a book and like writing and stuff.
Okay.
It's kind of like with technology, you get a code on your laptop, and then
The art?
yeah.
Okay.
You get to do like graphs and then like draw graphs.
So
and
you
stuff.
like doing the things
Yeah.
a little bit differently than just going, all right, here it is in the book, and this is what we have to read, or this is what we have to do, and just doing it like that.
Yeah.
So you like the STEAM activities that your school is doing?
Yeah.
Cool. Well, you know what? I know there are a lot of places that are doing STEAM and STEM activities and things like that. And a lot of students, like you were saying, the science, the technology, do you know what all the letters stand for?
Science, technology, engineering,
Perfect.
arts, math.
Math, there you go, right? The most important one, right? They say the most important one for last, right? So we are going to have you work on math problems from now until 5 o'clock, straight through. Are you good with that?
Yeah.
Okay, I'm only kidding. You don't have to work all the way straight through until 5 o'clock. We'll have you do a couple of problems later on this hour, okay?
Okay.
All right. But you know what? Just a reminder, we do have phone tutors available until 5:30. If you're calling from San Luis Obispo County and we do one of your math problems, you will automatically receive yourself some ice cream, courtesy of our friends at Doc Bernstein's Ice Cream Lab. Right now, we're going to go out. We're going to visit Devin. And I do believe he is ready with some students, ready to do a little bit of math.
Hey, thanks a lot, Mike. Back here at Longfellow Elementary School, right in the midst of a beautiful fall day here in Bakersfield. We've got a lot of friends with us across 4th, 5th, and 6th grade with us today here at Longfellow. And it was really interesting having the conversation about where everybody is and what they're exploring. What we're going to do is we're going to look at a little bit of each of those grades as far as what they're working on here at Longfellow. And we're going to start off with 4th grade. So we had a conversation with some of our friends here about the kind of multiplication they're exploring. And today, the 4th graders here, we're looking at multiplying by thousands. So I thought about this and, why limit ourselves with just thousands? So what you're going to see everybody working on right now are different varieties of multiples of 10. So we have them working on 4 different problems. They're all multiplying 4s, but they're doing different extensions of place values. So we're doing 4 times 2,000. We're also doing 4 times 100. We're also doing 4 times 30. And we're also doing 4 times 2. Now, one of the things we noticed is that there's a lot of different ways in which students are representing their understanding here. So, for example, we're looking at 30 times 4, which is interesting, sir, because, what was your name?
Daniel.
Daniel. What's interesting is that we had 4 times 30 up here, but you represented this as 30 times 4. So show us what you're doing to make sense of 30 times 4.
So I put it like this, so I can do this. So first I multiplied 4 times 0, and that equals 0. And after that, I multiplied 4 times 3, and then I got 12, and then I got 120.
Now, what's really interesting about what you did on the side here is you saw this as 30 plus 30 plus 30 plus 30. So your 30 added to itself 4 times. So you're using repeated addition to make sense of that. Does that work with some of those other problems as well? So
Yes.
could we do that with 100 as well? So
Yes,
4
we
times
could.
100. So give that a shot. And we're definitely seeing a lot of that same pattern here. We saw that as well with the drawings for the 4 times 2,000. And we see some area models here. Young lady, your name?
Right.
Right. Tell us a little bit about what you're working on here. So how are you doing 4 times? Are we doing 4 times 100 or 4 times
30?
30. So you're doing 4 times 30 here. So explain how you're doing that. So it looks like you're doing 4 times 10, and you're going to do another 10 here, another 10 here. So you're breaking that 30 into 10s, and then multiplying each of the 10s by 4. So this is a box of 40. And I'm going to predict, Mariah, that there's going to be another box of 40 here and another box of 40 there, right? No? How are you going to do that? I'm sorry to interrupt you. I just want to make sure that we can share your thinking with everybody.
Okay, add 40 plus 4.
Okay, so go ahead and continue on that. We're going to get back to you to see what that looks like. You're doing something very similar with 4 times 2,000, correct? So explain how you did this work.
I put 2,000 plus 0 3 times, and then did that, and then I put 2,000 times 4, and then 4 times that, and then 4 times, and then I put the answers on
That's
the
really interesting. What was your name?
Jesse.
Jesse? What's really interesting, Jesse, is that you took the number 2,000 and broke it down, each digit, by its place value. So what you're saying is you have 2,000s, 0 hundreds, 0 tens, 0 ones, and you multiplied the 4 by each of those place values. That's a really interesting approach. And what it shows is a way to make sense of each of the numbers in a number, each of the digits in a number, even though it's mostly zeros. It shows exactly what those zeros represent. And so that's really fascinating. So it looks like most of us have broken down each of these problems. So everybody, is it okay if we shout out our answers to each one of these? Yeah. So let's give this a shot. Ready? I'll start at the bottom. 4 times 2 equals? 8! Wow, these guys know what they're doing. 4 times 30 equals? 120! 120. 4 times 100 equals? 100! And 4 times 2,000 equals? 800! Now, we found all 4 of those. I have one more 4 times problem I want to see if we can put together. And I think that Jesse's got a clear idea of how this is going to work out now. Are you ready? It's this one. 4 times 2,132. Hey, don't those pieces sound very familiar?
Uh-huh.
Because how many thousands do we have here?
2.
Oh, how many hundreds do we have?
1.
So what do you think we have to do with all the answers we've already found?
Add it together.
So go ahead and try that out. Instead of launching right into an algorithm with carrying over and numbers, we break each of these digits down into its place value, and it doesn't matter which one you multiply first, as long as you add all those pieces together, which our friends here at Longfellow seem to have picked up very, very nicely. So they're going ahead and piecing those all together, which is nice because they've already found all of these values, as you heard so eloquently stated from our group here. So, is there anybody who's gotten a solution already? We've got a bunch. Let's see if we can shout that on the count of 3. 1, 2, 3. 8,528.
Oh, yeah.
Looks pretty good to me, Mike. Back to you in the studio.
All right, nicely done with that group activity and doing a little multiplying in a couple of different ways. 636-4357, we do have phone tutors available until 5:30. We'd also like to thank our friends at Johnny Rockets for donating a meal to Luke. So congratulations on coming down and getting a free meal for doing some math work, huh? Not bad?
Yeah.
All right, well, you know what? Let's get you doing some math work now, huh?
Okay.
All right, over to the board. Let's go. So in your book, you are working on, looks like adding and subtracting fractions.
Yeah.
So we're going to do, there's one you haven't completed right now. So 4/9 minus 1/6. So 1/6. So as you go through that, you've got Tracy to help you out, but explain to us how you would go about solving that problem.
Okay, so first you need to find a common denominator, which you can just multiply, and then it would be 54. So, and then 54. So then 6 times 9 is 54. So then you have to do 6 times 4. So that's 24. And then 9 times 6 is 54. And then you have to do 9 times 1 because 9 times 6 is 54. So then you have these, and then you minus these, which is, you only minus the numerators. So
You can work it off on the side if you need to.
15. And then, so it'd be 15 54ths for the answer. So 4/9 minus 1/6 equals 15/54.
Is there any way to reduce that maybe?
Yeah, if you want to simplify, then you can do if you want to simplify, then you have to do simplify both of them.
By the same number?
Yeah, by the
Okay.
same number. So half of 15. Wait.
It's okay.
Half of 15 is nothing.
So let's just back up really quickly because you're doing great. So this is, no, we don't want to say the, oh, no way, go away. Okay, so real quick, let's think about this really quickly. So we know that 2 can't go in there because this is not an even number. So can you think of something else that it might be able to go into?
Maybe
So you
3.
can't do 5. 3 would be a good one. Here, let me put my pen up. Okay, go ahead.
So if you divide by 3, then that would be 5, and that would be let's see. So that'd be 38. No, that'd be 18.
That's okay.
So 5/18.
So 5/8?
Yeah.
Okay. And I think we're done with that one, right? And 5/18?
Yeah.
So really quickly, remember how we were trying to figure out how to do this? And this was not an even number?
Yeah.
So we couldn't do 2. We can't do 5 because that doesn't have a 5. So there's a little trick. So if you add the two numbers, 5 plus 1 is 6.
Yeah.
And if you add 5 plus 4 is 9. 6 and 9 both go into 3, correct?
Yeah.
So any numbers that you can add them up, and they like a 3, 6, 9, you can always do the 3 into it.
Yeah.
Okay? You did great.
Thank you.
There you go. Nicely done. Now,
Yes.
what I'd like you to do is maybe on the other side,
We'll come over here.
go ahead and write 4/9 minus 1/6 again.
I'm gonna do it here. We'll trade.
So you're gonna do the same problem, but I'm gonna have you do it a little differently.
So
So go ahead all the way over to the left. Yeah, go ahead and write the problem again.
and put a minus there.
So what I'd like you to do this time is, because what you did was correct. You automatically multiply them and you got a common denominator of 54. But sometimes if you get larger numbers and you just do that, you're going to have a really big number that you're going to have to work with. So what I'd like you to do is see if there's a lower common multiple, a least common multiple for 9 and 6, so you don't have to work with such a big number.
Okay.
So if there's something smaller than 54 that 9 and 6 will go into.
Okay. So you have to multiply and then keep on doing it until you find the lowest common multiple. So
Can we stop though?
Huh?
Can we stop? Do we see something that we already
yeah,
have it on
18
there?
and 18.
Perfect.
So these two are the same, so that can be the denominator because it's the common denominator. So these can go into 18, and then 6. What can make 6 into 18? So 3, and then 3/18, and then 9 times 2 is 18. So then you minus these.
Hold on 1 second. So is it 4 or is it?
I mean, it's
You're good.
it's 8.
I didn't want you to have to do the whole problem. We had to do it over. Nice.
And the minus is 5/18.
Perfect.
There you go.
Much
Nicely
easier,
done.
right?
Yeah.
All right.
So we followed along with what you were doing. We know that the 8/18 comes first, because otherwise you would have negative 5/18, but you've got the whole thing right there. So nicely done. You can go ahead and erase that board. 636-4357 is the phone number. We do have phone tutors available until 5:30. Don't forget, today and tomorrow, the last 2 days of the 5th grade call-in contest. Right now, we have 4 schools tied for the lead. And hey, you know what? You've got until 5:30 this afternoon, and then you've got 2 more hours tomorrow. Also, all students that call in this week and next week will be receiving free tickets to Holiday Lights at COM, a lovely family tradition. We'll be back with more right after this. Today we're at Thomas Jefferson Middle School, and today we're here to... Today we're at Thomas Jefferson Middle School, and I've got Victoria, an 8th grade student, with me. How are you?
Good.
You ready?
Yep.
Let's go. Go ahead and read the problem for us. What have we got?
We got 9a minus 2 equals 4a minus 18.
What do we need to do with this?
We need to solve for a.
Perfect. So how would you like to go about starting this?
We can first, we can make a line right here.
Okay.
and like that. So it's like subtracting. Make it first -2 on both sides.
So you want to get all the numbers on one side and the variables on another side? Mm-hmm. Okay. So here we have a -2. Mm-hmm. So we want to get rid of that. So we do the inverse. So what do we need to do to this?
Add 2.
Add 2. Perfect. Because you said subtract 2.
Yeah.
And I think I knew you were talking about. And if we did it here, why are you doing it over there?
Because you have to do it on both sides.
To keep everything balanced and equal?
Yes.
Okay.
So this crosses out. And then this would be 18 minus 2 equals 16. And then it'll be 4a. And you bring everything else down. It'll be 9a.
So the only thing I need you to do right now is everything's perfect. You did the difference between 18 and 2 is 16. You brought down the 4a, the equal sign, and you brought down the 9a, which is the only thing left on this side.
Yeah.
But 4a, 16, are we going to add 16 or take away 16?
Probably
Because what was the symbol we already had?
subtract.
Subtract, right? Negative 18 and 2 leaves us with a negative 16, right? So we'll leave that at negative 16. Okay, now what would you like to do?
Probably the 9.
What do you want to do with the 9?
I could subtract.
You want to keep all the variables on one side?
Probably, yeah.
Okay, so if we have only a variable over here, what should we do with this?
Take it away.
Move that over here, right? Mm-hmm. Okay, so is that a positive 4a or a negative 4a?
Positive.
Positive. All right, so in order to get rid of a positive 4a, we have to, just like we did here, the inverse, right? So we'll subtract 4a.
And then on here?
Right, both sides, remember? Keep everything equal.
Cross this out. And it'll be 5a equals 16.
Positive or negative 16?
It'll be negative.
Negative 16. So now what do we need to do?
Divide
Divide by what?
5.
Perfect. And why are we dividing by 5?
Because it's the 5 is next to the variable, so we're going to take away the variable.
Right, so that's the coefficient, so we'll get rid of that.
And this crosses out. A equals, and then you'll do negative 16 divided by 5.
And we could just leave it in that form also, right? Okay, so why don't you just go ahead and leave it like that? And we solved for A. Victoria, nicely done. And once again, a big thanks to all of the staff and students at Thomas Jefferson Middle School. Always have a great time when we have the opportunity to go out and do a little math in your class at the various schools throughout Kern County, as well as San Luis Obispo County. Hey, if you'd like us to come out to your school, all you have to do is give us a call. The phone numbers are at the bottom of your screen periodically throughout the program. Simply let us know, hey, you know what? We'd like you guys to come on out, do a little math in our class as well. We'll take a look at the schedule, see when we can get you guys in. All right, right now we're going to go out and do a little math at their class at Longfellow with Devin.
Hey, thanks a lot, Mike. Back here at Longfellow Elementary School, home of the Lancers. I'm joined by Angelina and Scarlett, 5th grade, and today's lesson focused on powers of 10. Now, it wasn't really today's lesson. You started looking at this yesterday, but could you just kind of explain to us what exactly powers of 10 means?
You're most likely counting by tens.
So when we say counting by tens, are we going like 10, 20, 30, 40?
No, multiplying it.
So
You're multiplying it.
it's the number of times that we multiply a number by 10. Now, that can look a lot of different ways. And what we're going to be doing today is exploring what happens to numbers as we multiply by powers of 10. So right up here on our smart board, we have an example of 10 to the second power. Now, explain to us what this means.
That means like 100 because it's 10 plus 1, or I mean times. It's most likely 10 times 10.
So 10 times 10. So what does this number 2 have to do with anything?
It's telling you how many times to time it.
So the powers of 10, that number, the exponent above the 10 to the side, tells us how many times we're going to be multiplying with 10. So we have an expression that uses multiplication with 2 10s in it. 10 times 10, which we know equals 100. Right. Okay. So now let's have a prediction here. If I was to put up 10 to the third power, what would that expression look like?
It will be 1,000 because you're timesing the tens 3 times.
So we're multiplying with 10 3 times. So it would look like this. That's 2, so we're going to need 1 more. Now, what do you notice happened with the number of zeros as we went from 10 to the second to 10 to the third?
It added up.
So because the exponent is 1 more, there's 1 more 0? Now, what's also interesting is if you look at the total number of zeros in the tens that we're multiplying, what does it have in common with the number that we have that we end up with?
It's the same zeros.
So how many zeros do we have here?
2.
So how many zeros do we have in 100?
2.
And what is the exponent for 10 to the...
Second.
So we start to see how that 2 ends up showing up a lot. Does the same hold true with this, with 10 to the third?
Yes.
How so?
Because it has 3 zeros in the timesing, and it has 3 zeros in the answer.
So when we say this, so when we're multiplying with 3 tens, we're really multiplying with 3 zeros, and we end up with a value that has 3 zeros. So your challenge, everybody in the room is going to be working with this, is to try to fill in what they think 10 to the fourth would equal, and 10 to the fifth would equal, and what that expression would look like. So they're going to work on that, and I've got a challenge for you. They're working to greater exponents. We are going to work with lower exponents. So following this pattern, what do we think 10 to the first would look like?
It's just 10 times 1.
Just 10? Well, I think we're getting to the idea that it's 10. Are we necessarily saying 10 times 1?
It will be like...
We have an expression that uses multiplication that only has 1 10 in it, right? So really we don't need a multiplication symbol. Now, with that said, you notice a pattern. 10 to the third has 3 zeros. 10 to the 2 has 2 zeros. 10 to the first has 1 0. So, what do we think 10 to the 0th power would be?
0.
Now, let's see if we follow this pattern. Your guess is that it's 0. Why do you say 0?
Because it has no other 0.
And if you multiply 10 times 0, it would just equal 0.
Now, are we necessarily multiplying these two together?
No.
No, all we're saying is how many tens are in that multiplication. Now, I want to go back to this pattern because I think this is really helpful for us to build understanding. We have 1,000 for 10 to the third. I think you're starting to see something here, right? We take away that 0, we're left with 100. We take away this 0, we're left with 10. So what happens when we get to 10 to the 0th power and we take away this 0? What is left?
1.
So 10 to the 0th power
Equals 1.
equals 1. So the fascinating thing about 10 to the 0th power, as you explore powers of other numbers that aren't just 10, is that no matter what that base number is, if the exponent is 0, it'll always equal 1. So you can have 3 to the 0 power. It's 1. You can have 999 million to the 0th power. Equals 1. My challenge to you, and this is going to go next level, and if we don't work on it now before we send it back to the studio, and if you're thinking about this at home, use the pattern and think about decimals too, okay? What about 10 to the negative first power?
You're going to start using this.
You're going to start looking like decimals, right? So what do you think this would be if we follow this pattern? 1,000 divided by 10, divided by 10, divided by 10. Because that's another pattern as we go lower, right? Because if we go up in the exponents, we're multiplying by 10. But if we go lower in the exponents, we're really dividing by 10. So 10 divided by 10 is 1. How would we express 1 divided by 10? What would that look like?
It will probably look like just like maybe just like really nothing.
It'd be a very small number. You're absolutely right. But do we necessarily have to use a decimal to show that? Because there's another tool in math that we use to show division. A fraction. Right? If we think about 2 divided by 3, we can write that as 2/3. If we write 1 divided by 10, how could we write that?
1/10.
1/10. And if we put that as a decimal, 0.1. Now, what do you notice about the number of zeros in this fraction, in the denominator? There's 1. I want to see if Angelina and Scarlett can rise up to the challenge of 10 to the -2nd power. And I want to see if you at home can do the same thing as well. But for now, we're going to send it right back to Mike in the studio. Mike,
All right,
take
thanks
it away.
for that,
We've
Devin.
got our work cut out for us.
All right, maybe we'll have Luke do that while he's waiting next time we go out there and visit with you guys. But nicely done by Scarlett and Angelina working out there at Longfellow Elementary. We do have phone tutors available until 5:30. Right now, it's time to get Luke back to work. Back to the board, young man. No more of the easy fraction like you were doing before. Now we're going to add mixed numbers.
Okay.
All right, so here's one out of your book. Let's 8 1/6 plus 7 3/8. So explain to Tracy, if you would, how you want to solve this problem.
So you'd put this number back up here, and then so that'd be 10. No, it'd be because.
So first of all, so what does 8? And let's try it with 8 real quick. What does 8 represent?
It like you can divide. This number was 8 times.
So 1 whole of these would be equals 6/6. So
Yeah.
before you do this part, you have to 6 times 8 and then plus 1.
Okay.
So go back to that one, and then I'll let you do that one.
So 7 times 8 is 56.
And then you have to
And
add.
then add plus 3,
Perfect.
so 59. I'm going to erase this. Okay, so 59 eighths plus 48 plus, so 40, 49, 49 sixths.
That's good. No, go ahead. You can write plus right here.
Plus
And then
59 eighths. So then,
hold on 1 second. There you go.
common multiple, and then so 8 and 6, and then 16, 12, 24, and then 18, and then 24. So then 24, 24. So 24. 20.
So 6 times what makes 24?
4.
And then 4 times 49. So we're making you do the long way, huh?
Yeah.
I'm going to show them how to do the easy way. So 8 times 24
is 3.
3.
So 59.
You can come over here.
It's 3.
Hold on one second. Let me move it up for you. There you go.
27, and then 15.
And you forgot to add the 2?
17.
I didn't want you to get through the whole thing. And we were
Yeah.
like, oh, wait. There you go.
So 177.
Do you want to rewrite it?
Yeah.
Okay, so hold on. Let's go back down. Oh, we're going to rewrite these 2 right here.
196 over 24 plus 177 over 24. So 196 plus 177 is 4.
Well, hold on now. You got 1, 9, and 7, right?
Oh, yeah.
So this is, it's just this one right here. So we're going to erase that, and we're going to erase that. So we have 9 plus 1 is 10 plus 7. So that's
Oh, I
17.
multiplied. I multiplied.
So
16.
So it's 17.
And 3, so
So it equals?
equals 374.
73.
Oh,
I like how you do money, though. I'm going to have you do my checking account, though.
73.
'Cause you keep adding lots to it.
24.
Perfect.
So, where's the original one?
I would say go all the way over to your left to do your division
So
now.
let's come over here, and we're going to do the 24, and we will divide into 373. No.
So 24 goes into this once.
Hold on real quick, just so we don't mess it up. Okay, now go.
Okay. 3, 13. So bring this down. And then 133. Divide by 24.
So this,
This just helps so much.
so this is how I kind of, we guesstimate kind of in our class, or an estimation. So I kind of make that 25. So I go 25, 50, 75, $1, $1.25. So it can at least go 5 times. So
Okay.
you can try 5 first.
5 times 25.
Well, 24.
10. So, yeah, it'd be 5.
Okay.
So 5, 120. That's 13.
So how about we leave it right there, and we'll do 15, and we'll do 13 over 24. Okay?
Yeah.
Now we're going to do it the easy way?
Right, so remember that your answer is, I'll just go ahead and jot it down in his book here, 15
Okay.
and 13 over 24.
Correct.
Yeah.
So let's go back to the original problem. You guys can just get rid of all of that if you want. We'll rewrite it.
Okay. So, oh, I forgot I have my handy letter. There we go.
There you go. All right,
Okay.
so we have 8 and 1/6 plus 7 and 3/8.
Seven and 3/8. So, the easy way?
Yeah, the easy way.
So 7 plus 8, 15. And then,
So I'm going to cross these off so we know we've done it, okay? So this one and this one are now here, okay?
Okay.
So now we'll do
So-
the fractions.
1/6 plus 3/8.
And we already know the
common
common.
denominator is 24.
Perfect.
And then 6 times 4. So 4. And then 24. This goes into 24 3 times. So 9. And then, so 13. 24. So 15.
Phew, that was way easier
Yeah,
that
that was
time
way
than it was,
easier.
right?
You like that way? All right, so why don't you erase the board so you came up
Okay.
with the same thing right there. So
Okay.
now what we'll do is we'll go ahead and we'll do a subtraction problem and see if it works out the same way, like that.
Yeah.
All right, so here we go. 2 5/8 minus 1 1/4.
So the long way? Okay. So 1 times 4 is 4. And then 2 times 8 is 16.
So you, just real quick, so we forgot to add it. So 4 times 1 is 4, but we have to
Oh, yeah,
add the
plus
1,
one.
so it's 5. You're good. It's be 5 over 4.
Oh,
So it's 5 over 4. Perfect.
4.
Okay.
16 plus 5. 21. Right, yeah. No.
No, you're good. We're just going to erase that. Make that an 8. Okay, now you're good. Okay.
Okay. Oh. Disappeared.
Just went away? What?
Yeah.
Ah, there we go.
Okay, so then need to subtract this. 8 is the common multiple. Yeah. So 21 over 8, and then 4 times 2 is 8. So you have to multiply the 5 times 2, so 10 minus, and then equals 11 over 8. So now we have to put it into mixed numbers. So 1, 3, 8.
Okay, that was a little bit of a long way. You want to do the short way again?
Yeah.
Okay. So I'll trade you pins. So we'll write it in red over here. You just did the 2 5/8.
Minus 1 and 1. Oops. So 1 minus 2 is 1. And then 5/8 minus 1/4 is so the common denominator is 8, and then 4 times 2 is 8, so you have to do that, and then 5 3/8, so 1 and 3/8.
Looks like they're the same.
Yeah.
Did a great job.
All right, there you go. Nicely done. Now, you can go ahead and erase the board. You've done excellent work with both of those. So I'm going to give you an option of your last problem to work on. Would you like to add or subtract?
Subtract.
All right, subtraction it is. Now, you don't have to do this both ways. You can do it either way you want.
Okay.
All right, so here we go. Let's find the next one. All right, 12 3/4 minus 6 1/6. So you can do it either the long way or the shorter way, whatever way you're more comfortable with, but you only have to do it one way this time.
So 12 minus 6 is 6. So I'll just cross those out. And then 3/4 minus 1/6 is, so we have to find our common denominator. 8, which is 12, So 12. 4 times 3 is 12. So you have to do 3 times 3, which is 9. And 6 times 2 is 12. So you have to multiply the 1 by 2. So it's 2. That is 7 twelfths. And then 7. Okay.
That was way easier than the other ones.
Yeah.
I know, right?
All right, nicely done with you two over there. Come on over here, Luke. Hey, we do have phone tutors available until 5:30. 636-4357 is that phone number. Don't forget, because you're in here, you now have a phone call credited towards your classroom, towards that 5th grade calling contest. So you've got about 40 minutes left on today's phone tutors. You can get a hold of people till 5:30. And then tomorrow is the final day for the 5th grade calling contest. So when you go back to school tomorrow, what do you need to do?
Ask my teacher about it.
Ask your teacher, what was it, Ms. Martinez, you said?
Yeah.
All right, so you can say, hey, listen, you heard about this 5th grade calling contest going on with Do the Math? She'll go, yeah, Luke, I thought you knew all about it too. And you're going to go, well, you know what? As a matter of fact, I do, because I was on the program yesterday, and I'm a step ahead, because you guys are working on fractions right now, right?
Yeah.
But you haven't got to mixed numbers yet, which is why I wanted to go to the next little section in your book, so that you kind of got a little head start on that right there.
Yeah.
So do you kind of feel comfortable with those?
Yeah.
Which way did you like better?
The minus, the one that you got to, the one that you didn't have to make an improper fraction.
Right. See, because if you can find little shortcuts and things like that, it's going to make life a little bit easier.
Yeah.
Right? Just like when you were doing the common denominators, instead of always multiplying them, you can look for the least common multiple first. And sometimes it just happens to be when you multiply, and that's what it is. It happens to be that. But always look for a shortcut if you can.
Okay.
As long as you have the concept of what you're doing. All right? All right. Hey, you know what? We do have an opportunity to go one more time out to Longfellow and visit with Devin and see what those guys are doing. Wrap up the afternoon. What do you got going on, Devin?
Hey, thanks a lot, Mike. Back here one last time here at Longfellow Elementary. I'm here with Imani and Malachi, 6th graders here. We were having an interesting conversation about greatest common factor. And, factorization. Factorization is always an interesting word to me. You know why? It's pentasyllabic. That means it's got 5 syllables in it. Which is interesting because the word pentasyllabic has 5 syllables in it as well. So it's a word that kind of describes itself. But that's for do the English. Today we're going to do the math. And we're going to talk about greatest common factor. Now, the way that we're going to do that is we started talking a little bit with some of the other 6th graders in the room about how they found greatest common factor. And a lot of times it's a lot of dividing or trees or factors or multiplying up, we heard, as another method. And so I wanted to go back in time a little bit and explore how we can use geometry and how the ancient Greeks actually used that to develop their own method for greatest common factor. So let's go ahead and take a look up at the board and see what's set up here. So what we built is a rectangle. So could you guys explain this rectangle, describe it as far as its dimensions or what you notice about it?
Well,
It's way smaller than a square.
Okay, so it's got a lot of smaller squares in it, right? How would you describe how long this rectangle is?
12 and 8.
So 12. So it's 12 units across. All right. Let me go ahead and get them curl here. 12 units across, and it's 8 units tall. So now, I want to see if we can explore this a little bit, and I have a question for you. What is the largest square that we can fit into this rectangle? How large would that be?
8 by 8.
An 8 by 8 square. Could you do me a favor and kind of draw that out, and then once you have it drawn out, I would like you to do something. So let's draw out an 8 by 8 square. So it's 8 across, and Imani's drawing an 8 tall and coming back this way. So this is an 8 by 8 square. Could you do me a favor? I know this is going to hurt. I need you to cross it out. Goodbye, 8 by 8 square. We're going to get rid of it. It's gone. It doesn't exist. So let's describe what's left here. What do we have that remains from our original rectangle?
A 4 by 4.
This is 4 by 4, so we have 4 across and
4, yeah.
is
4 by 8.
It's 8, right?
Yeah.
So we have a 4 by 8 rectangle. Malachi, what's the largest square we can carve out of that remaining piece?
4 by 4.
Let's get rid of a 4 by 4 square. Okay. It doesn't matter which one, whether it's on the top or the bottom. So he's going with the top upper right corner. Go ahead and cross that out. It's got to go. No love for you, 4 by 4. Now, what do we have left?
4 by 4.
So what would that be a square?
Yeah.
Okay, so we're left with a square. We're going to keep this one. This is a 4 by 4 square, which means the greatest common factor of 12 and 8 is 4. Now we could try that again. We can do this with any two values. We build a rectangle, carve out the largest square possible until we're left with just a square. So let's try this with a 16 by 6 rectangle. So let's find the greatest common factor of 16 and 6. So it's 16 across, 6 vertical. What's the largest square possible?
6 by 6.
6 by 6.
6 by 6.
I'll even start off on this side here. 6 by 6. Now, this rectangle that's left is still 6 tall, but now how long is what's remaining? Because we had 6 over here, and we got rid of that. It was 16, we got rid of 6. What's left?
10.
10. So now we have a 10 by 6 rectangle. What's the largest square possible we could carve out?
6 by 8.
Still 6 by 6,
Yeah,
right?
6 by 6.
So we'll get rid of another 6 by 6. Cross it out. We got rid of 6 from the 10, so now how long is this rectangle that's left?
4 by 4.
So it's 4 across, and how tall again?
4.
1, 2, 3, 4. Now that's going to be the largest square remaining, right? So we get rid of that. Now we got rid of 4 from this 6 and its height. We have 2 left and 4. What's the largest square remaining?
2 by 2.
2. We'll get rid of that square. So what's left is a 2 by 2 square. It's a square, which means the greatest common factor of 16 and 6 is 2. Now this works with any two numbers, even when they're relatively prime. Even if the one square that you have left is just a 1 by 1 square, that means that the greatest common factor is 1 by 1. Now, we can take this as a shortcut. Instead of doing all of this rectangle work, we can just do subtraction and get to the same point. So let's try this. 16 minus 6. Those are our
10.
two values. What do we get?
10.
Now, here's what I'd like you to do. Get rid of the largest number here and subtract what's left. So what's left? We have a 10 and a 6. So we'll do 10 minus 6, which equals?
4.
Let's keep doing this. 6 minus 4 equals? 6 minus 4, because we have the 6 and 4 left. We subtract it. We have 2. Get rid of the largest. 4 minus 2.
2.
It's 2.
Get rid of the largest. I'm going to get rid of that. So I have 2 minus 2, which equals?
0.
Once you get to 0,
The bigger common factor.
there's your greatest common factor. 2. 2. 2. That's all great. What do we do with that? If we had a fraction where these are our terms, we could simplify it and reduce it by that greatest common factor. So it's one step. Imani, Malachi, 6th grade. Hey, everybody, 4th through 6th here at Longfellow. A lot of energy, a lot of heads up, a lot of collaboration. Not bad for a first time go around. Hey, can we say thanks to everybody here at Longfellow Elementary? Guys, wonderful job this afternoon. That'll do it here from Longfellow. Mike, back to you in the studio.
All right, thanks for that, Devin. Nicely done with all of the students out of Longfellow. Luke, thank you for coming in today. And your final duty of the afternoon, you don't need to do the problem two ways anymore. Simply pull out one of the kids from Longfellow, and we'll find out who's going to a CSUB athletic event of their choice. And there we go, Malachi. So congratulations, Malachi out at Longfellow there. You've got yourself 2 tickets to a CSUB athletics event. Congratulations on that. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Holiday Lights at Com, Kern's 3 million light extravaganza, is back celebrating 15 years of delighting kids and adults. See exciting displays throughout the Com grounds. Back are free carousel and train rides with holiday and historical displays dotted along the tracks. Holiday Lights was voted Bakersfield's best annual event and named one of the top 10 light shows in the western states. To see Holiday Lights, take Alfred Harrell Highway in northeast Bakersfield between Hart Park and Lake Ming and look for the lights in the sky.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are live today at Roy W. Loudon Elementary, home of the Letters! And we're here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Tracy. And you can reach us at Bakersfield 636-4357. You can reach us in San Luis at toll-free 1-866-636-6284. We have email, dothemath@kern.org. You can watch us online, dothemathonline.net. And we have social media, Facebook, Instagram, Twitter, and YouTube.
All right, just a side note on the email. If you do email us a problem, you'll want to do that before 4 o'clock tomorrow afternoon, because tomorrow afternoon is the final day of live broadcasting for the year 2017. After tomorrow afternoon, we will not be live again until the new year 2018. So if you do need to email something, you need to do that today, tonight, tomorrow morning sometime, but before 4 o'clock tomorrow afternoon. That way we can have an opportunity to take a look at it, possibly do it on air for you, and at least get an answer back to you if you need to send in a problem like that. A reminder also, we have Holiday Lights at Com. We have tickets to give to every single student that calls in to do the math, and we do your math homework on TV for you, so you can get yourself a pair of tickets to Holiday Lights at Com. That event has just started recently. I think December 1st was the first day of that, and it will be going through the new year, I do believe. So
Yep.
I think a little bit after.
It's like the 6th, I think he said.
So right before we come back to school, it'll be going all the way through then. Have you had an opportunity to attend Holiday Lights at any time?
A couple years ago, but not recently. It's beautiful, though.
Indeed it is. Well, you know what? Maybe we can get you out there again this year.
That'd be nice.
All right. We have a very special guest in studio. We will be going out to Loudon Elementary School in a little bit. But first, let's take a look at today's Math in the News. Well, especially this time of year, there are an awful lot of events going on around town. And Do the Math happened to be at one of them. The Bakersfield Condors again hosted students from throughout the area last Thursday for the annual Field Trip Day. It was the largest crowd ever for the event and second largest to attend a single game in Condors history. Our cameras are there to take in all the fun, live streaming directly to Facebook as students arrived at the Rabobank Arena in downtown Bakersfield. We also captured some of the fun in the stands and on the ice where the Condors faced off against the Stockton Heat.
3 lucky students. You can see Devin right there for a first period timeout to test their math skills, getting some help from the crowd, of course, and each walking away with a limited edition Do the Math shirt for their great efforts. As always, a lot of fun out there, but you don't necessarily have to wait until next year to attend a game. Throughout the season on Do the Math, we occasionally give out tickets to our callers. All you have to do is give us a call, and who knows, you might see the puck fly across the screen, and you could be going to see the Bakersfield Condors simply for doing a math problem. How are you today?
I'm good.
Have you ever been to a Bakersfield Condors hockey game?
I have.
You have? Did you have fun?
Yes.
Well, good. That was the main thing. Did they win, or do you not
Yes,
remember?
they won.
Well, good. Even bonus right there, huh? Well, in studio with us right now, we have Karis. And Karis, why don't you let everybody know where you go to school and what grade you're in?
I'm in 6th grade and I go to Williams Elementary.
Home of the Pioneers. You like it over at Williams? How long have you been there?
This is my 2nd year.
2nd year. All right. So, what is the best thing about 6th grade so far?
I think it's how everybody's starting to focus more on everything and how you kind of become closer to friends too.
There you go. So you guys are growing up, right? You're getting a little more mature. You're focusing on things. You guys got to get ready for junior high. Right? So you can make a lot of new friends next year also. All right. You ready to do a little work?
Yeah.
All right. You know what? We've got a couple of minutes before we go out to Loudon. So why don't you head on over to the board. We're going to take a look at your homework right here. And it says we need to convert decimal division expressions to fractional division expressions to create whole number divisors. So I can see you got started on this, but we're going to help you out with a couple of these right now. So what we'll do is we'll start with, let's just go on to number 3. So we have 3.43 divided by 0.035. So Karis, as you go through this, if you would explain to Tracy what you're doing, and if you get stuck, that's why you've got Tracy there.
Okay, so what I'm going to do is I'm going to put this into fraction form, which is 0.43 over 0.035. Now what I'm going to do is I'm going to change the divisor to a whole number to make it easier to divide. So I'm going to multiply this by 1,000 to make this a whole number, which equals 35 over 3430.
Okay, so let's move this up a little bit, and then you'll rewrite that.
So now what we're going to do is we're going to try to find a number that goes evenly into 343. So
you're going to put it all right here?
Yes.
Okay.
35 times 7.
So are you just randomly kind of estimating maybe?
Yes.
Okay.
So that we can see if we need to go lower or higher to find the right number. So we need to go higher.
So we already started with 7, so you're going to kind of estimate it again. So what do you think we could go? If we were at 245 and our number's 343, about how many do we need to get up?
Probably we need to go to, I think we need to go to 9, because if we go to 10, then it'd be too much.
Okay.
So I think 9 would be around the right number.
Perfect.
Wait, yeah, okay. So we're gonna do
And what did we have before when we had the 7 there? How many did we have? So it was 7 times 35. Do you remember what we had? It was like
245.
So we'd kind of be close.
So maybe 8.
You want to try 7 and see
Yeah.
what it is? Okay. So we know it was 245.
So
Well, hold on there, girls. You tried 7. You know what 9 is. What's wrong with 8?
I feel like it'd be too high.
Do me a favor and just try it.
Okay.
That's okay. We'll write over it.
Okay.
Okay. Oh, it's perfect. He made things easy for you, huh?
He did.
He did.
There's your answer. 98.
Very nicely done.
There you go. Nicely done. Now, what I'd like you to do is stop. Go where you put your minus 280 down below. Erase that. So we had minus 280 and all the zeros. Erase that. Or actually, you know what? Extend the screen forward, Tracy.
Got it.
All right. So, Karis, what I'd like you to do is put 280. So just go ahead and write 280. And if you multiplied by 7 like you were going to do, you were going to get 245, right? Well, you don't have to multiply by 7, but to put the 245 underneath that.
So it would be like this.
280 minus 245.
So it's 280 minus 245 like that.
So what I want you to do is, if you had done that with 7, like you were going to, see what would have happened, and then what you would have had to do next.
So I would have to go and...
So you would have seen
So you would have had 97 up on the top, right? Instead of 98, but then you have that left over, 35.
So 97 and a 10, because then you'd have to go 350, because 35 times 10 is 350. So you go 350 and you would get your answer.
Which would then change this, you would move that over, so then it would make it a 98.
Yes.
Right? Very nice.
Are you good on that, though? You see what would have happened there?
Yes.
Okay, that's why I wanted you to go try 8 first.
Okay.
Because sometimes students will go, oh yeah, I'll put 7, and then they go, oh, I've got a remainder, and it works out exactly to go in again. And that's one thing that would happen. All right, girls, you know what? You can go ahead and erase that screen right there. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. Programming note, today, December 5th. It is the 5th today, right?
Yes.
Yes.
And tomorrow, the 6th, will be the final last 2 days of live broadcasting for the year 2017. So tomorrow, the 6th, will be the last day of live calls until we come back in 2018. And right now, speaking of live, we're going to go live out to Loudon Elementary and visit with Mary Lou.
Thanks, Mike. We are live today at Loudon Elementary School, the ACES After School program, and I have a special guest with me today. Why don't you introduce yourself and let everybody know your name and your grade?
My name is Alyssa, and I'm in 5th grade.
Alyssa, what's your favorite thing here at Loudon?
My favorite thing is probably our reading, because I just like reading a lot, and we do a lot of reading here.
Well, I like to read too, but my favorite subject is math. So, and we have a math problem behind us, right? Okay,
Yes.
Let's look at this. It says 2,853 plus blank equals 4,205. Now, we know that when we're adding numbers together, we have a part of a number plus another part of a number equals the whole thing, right? And actually, we're doing something like this with my 7th graders today, okay? We're talking about a part and a whole, and we're actually doing percents with this. But how can we figure out our unknown part here? What do you think we need to do?
We could figure it out by subtracting.
Very good, because what is the opposite of adding?
Subtracting.
Subtracting. Okay, so Alyssa, let's go ahead and subtract these numbers. Go ahead and write this number for me first, because we're always taking the whole and we're subtracting from the part, aren't we?
Yes.
So we have our 4,205, and we're going to subtract that from 2,853, because we're working backwards, aren't we?
Yes.
Okay, why don't you walk this through us on how you're going to solve that?
So first I'm going to subtract 5 minus 3, which would equal 2 because 3 plus 2 equals 5. And then now we're going to go on to 0 minus 5, but we can't subtract 0 from 5 because we can't subtract 0 from 5. So we would cross out the 0, and we would cross out the 2 and make that a 1, and we would make the 0 into a 10, and 10 plus 5 equals 5. But now we have 1 minus 8 and 1. We can't take 1 away from 8, so we would cross out the 1. We would come over to the 4, make that a 3, and we would make the 1 a 11.
There you go.
And so 11 minus 8 is 3, and then 3 minus 2 would equal 1.
Very good. Now, can we double check our work to make sure we did it right?
Yes.
And we could do it by simply adding those together, right? Okay, so what I want you to do right now, and the rest, we have a couple other groups in the room, and each group is going to have to solve this problem. So Alyssa, you're going to go ahead and give us our first number, okay? And our first number needs to be in the thousands, okay? So write any number that you want that's in the thousands right here for us.
Okay.
Everybody have their pencils ready? Yeah? Okay. Okay, so she gave us the first part plus, and I'm going to give you guys the whole. So each one of you guys, each group, you guys need to determine what this is. You guys ready? Yeah? Okay, here we go. $12,034. There you go. Get working. While you guys are trying to solve this, we're going to go over here to our next problem. Andrew spent $37.50 for 3 robots. Each robot cost the same amount. How much was each robot? Now, when it says each, that means that we need to divide. Very good. Okay, so do a division house for us. And let's go ahead and put $37.50 in there. And don't forget, there you go, your decimal point. And let's put 3 on the outside since we're dividing by 3, okay? Because each robot costs the same. So we're breaking this up equally into 3s is what we're doing, okay? When we're dividing by decimals, all we need to do is bring your decimal point straight up. Just bring it straight up. There you go. You guys busy? Anybody have it yet over there? Any groups yet? Okay. So let's start by dividing. 3 divided by 3 is what?
1.
Let's put a 1 over that 3. And we know 1 times 3 is?
3.
And we know that equals nothing, huh?
Yes.
Bring down your 7. 7 goes into 3 how many times?
That would probably be 2.
2, good. Put a 2 up there. And what's 2 times 3, Alyssa?
6.
Okay, put a 6 and subtract. How we doing, guys? Good. One group's ready? Yes? Okay. So now bring down your 5. And 3 goes, how many groups of 3 go into 15?
5.
Very good. Put a 5 up there. And 5 times 3 is?
15.
There you go. And can 3 go into 0?
No.
No, because you have no remainder left, do you?
No.
And there's still a number, but 3 can't go into 0, so what do we put here?
0.
0. So, Alyssa, how much does each robot cost?
$12.50.
$12.50. There you go. Good job. And we could double check our work by simply going $12.50 multiplied by 3. Let's go check our group. Okay, who has it? Who has it? Okay, I'm going to go here because their hand was first. You guys, you agree on an answer over here? Yes. You guys agreed on an answer over here?
Yes.
Okay, so what was our answer?
8,778.
Okay, so let's look at this group. What did you guys think?
8,778.
So you both have the same answer. Yeah. This group, have we gotten anything yet? Okay, oh, you have it. What did you get?
8,778.
What about you guys?
8,778.
There you go, by simply subtracting, right? If we know the opposite of adding is subtracting, can we always work backwards to get there? Yes? Just like that division problem. If we know the opposite of multiplication is division, can we get there? Yes? Yeah, that's what's so wonderful about adding, subtracting, multiplying, and dividing. All right, well, thank you so much. You did a great job. All right, we're going to send it back to you at the studio.
All right, nice work by the Leopards over at Loudon Elementary, and thank you for that, Mary Lou. We do have phone tutors available until 5:30, and everyone that calls into the math program today and tomorrow will be receiving 2 tickets to Holiday Lights at Com. We'll go to the phones right now, and Morgan, how are you this afternoon?
I'm good.
And you are a 6th grade student at Lum, correct?
Right.
All right, as soon as you're ready, let's hear the math problem that you're working on.
So Gerald is making candles from beeswax. He has 132.72 ounces of beeswax. If each candle uses 8.4 ounces of beeswax, how many candles can he make? Will there be any wax left over?
Okay, so what I'm hearing is you have
Here we go. I'm going to help you out.
Okay, great.
We're going to move this paper up to number 12. All right?
Okay.
So, Morgan, what I'd like you to do is look at the screen right now. Is your problem the same as number 12 on the screen?
Let me see.
Does that look familiar?
Yes.
Ah, there we go.
Okay.
So, Karis was going to work on this. So, here's what we're going to do. You, over to the board.
Oh, yay.
You're going to help since this is one of your homework problems as well.
Yay.
All right?
Okay. Thank you, Morgan.
Morgan, you and Karis together are going to work through this problem.
Okay.
All right? Tracy will do nothing except stand there and help if needed. So, here we go. 132.72 ounces of beeswax. Each candle uses 8.4 ounces. So the question is, how many candles can they make, and will there be any wax left over? So, Karis, what I'd like you to do is you ask Morgan how to go about this problem, and you'll be writing it up there, and you two will talk about how you want to solve this.
Okay, so Morgan, how are we going to go about doing this problem?
So I want to put 132.72 in the division house and 8.4 on the outside.
Okay.
So Morgan, go ahead and keep walking her through this.
Okay. So here's the part where I kind of got stuck on. Our teacher said, I think she said that there can't be a decimal in the 8.4, but I'm not so sure how to move the decimal.
So Morgan, I'm going to let her do the problem. If you're watching the screen, I'm going to let her do it the way that she did earlier by multiplying it to show you, just so she can show you her way. So I'm going to let her talk. So if you're watching the screen, she's going to walk you through it, okay?
Okay.
Go ahead.
So what you're going to do is you're going to put 132.72 and then draw a line, and under it put 8.4. Now 8.4 is going to be the divisor. So we have to make the divisor a whole number, so what we're going to do is we're going to multiply both numbers by 10, because whatever you do to the bottom, you must do to the top. So it's going to be 132 and 7.2 over 84. And
now,
then,
before you move on, Karis, Morgan, do you understand what just happened right there?
Yes.
Okay, because by multiplying it by 10, you're making that 8.4 into a whole number, and the numerator is just going to move over one decimal. So you're good with that?
Mm-hmm.
All right.
okay, so now what we're going to do is we're going to divide. It's too close.
So before we get started, Morgan, can you help her on dividing now? Now that you understand that, can you help her with the 84 that goes into the problem now?
Okay.
Okay.
So, $84 goes into 132 one time. So subtract 132
Right there.
by 84.
And so, Morgan, what did you get when you subtracted it? Did you get 48?
Yes.
Okay. Go ahead.
And then you're going to bring down the 7, and then we're going to find another number to multiply by.
So, Morgan, what number would go into 487? So we're going to help you out a little bit. I think she already put a 5 up there, which would help you. So she's going to work the problem up here, and you work it at home, and we'll see if we get the right answer, okay?
Mm-hmm.
So Morgan, we got 5, and 5 times 84 made 420.
Yes.
Okay, so now she's gonna go ahead and subtract that. So now we have 672, and we still need to go 84 into 672.
So here's something for you girls to think about. Instead of just randomly selecting a number between 1 and 10 or something like that, you know that you're going to be multiplying something times 84. So think of the last number 4. You know you want to, if it can, end in a 2. So 4 times what will end in a 2? Because 4 times 2 is 8. That's not going to work. 4 times 3 ends with a 2 because that's 12, right? So you could try 84 times 3, but then think about 8 times 3 is 24, right? Mm-hmm. And that's nowhere near 600, right? So what other number times 4 will end in a 2?
Morgan, do you know what would end in a 2 if you times it by 4?
Or Karis, either one of you.
Go ahead.
I'm thinking 6 or 8, I think.
Because 4 times 6 would be 24, so that ends in a 4. We don't want to try that. So what one did you think other than that?
8.
8. So does that make sense, Morgan?
Yes.
Okay, so try 84 times 8, because we know 8 times 4 will be 32 and will end in a 2. And we'll see if we get lucky here with this.
So your final answer is going to be
15.8.
So do you have that, Morgan? So I want to make sure that you've got the correct answer before we let you go here. Did you do the 84 times 8?
Yes, but I think I got the wrong answer. So.
Well, do you have a calculator there? Because I know on the homework it says you need to check it with a calculator.
My teacher told us to check it with multiplication instead of a calculator.
Well, there you go. That's what I was going to say. Also, you can check it with multiplication. So go 84 times 8. So do that. I want to make sure that you get the 672 out of that while you're multiplying it.
Oh, yes, I did. I realized my mistake. Thanks.
And then while you're doing that, Tracy will go ahead and write it, and then she will go ahead and do the verification on this.
Do you want to do the verification?
Sure.
Okay, I'm gonna let you do it.
So how are you doing, Morgan?
Good.
All right, so did you get 15.8?
Yes.
Okay, so now let's go back to the question because it is asking specifically how many candles can be made. So how many candles can be made, girls?
15.
Well, the answer is 15.8 though.
Yes, but if you don't have enough for one, then you can't make a candle.
Does that make sense, Morgan?
Mm-hmm.
Okay, so the answer to the first part is how many candles?
15.
15. Now the second part is, will there be any wax left over?
The answer is yes.
Right, because it doesn't ask how much, and you can put that on there, but the simple answer is what they're asking for is simply a yes or no.
Yes.
So Morgan, does all that make sense to you?
Yes.
All right, I just wanted to make sure that you don't put 15.8 as the answer because the question was how many candles can you make and will there be wax left over? Well, Morgan, since you phoned in this afternoon, we will be sending you home with a meal courtesy of our friends at Chick-fil-A, so congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30. We'll make Karis do some more work. Maybe we'll make you work with the students calling in again, and we'll do all of that right after this. Today we're at Thomas Jefferson Middle School, and today we're here to... All right, today we're at Jefferson Middle School, and I've got Anthony with me. You ready to go? Mm-hmm. All right. Today we're going to compare ratios. So the first one we have is 9 to 15. And we're going to compare that to 8 to 20. So this is one way to write ratios. We could also go 9 to 15, okay? Mm-hmm. Or we could go 9 to 15. There's a bunch of different ways to write ratios, yes. Okay? And we just want to compare them. We want to see, is this one greater than, less than, or equal to 8 to 20? Mm-hmm. So how would you like to go about working on this problem to figure out if this is greater than, less than, or equal?
With the fraction.
With the fractions? All right, so go ahead and put the first one, 9 over 15. And then we'll put this in there so we can put our symbol, and then 8 to 20. So how are you going to figure out which is which? Like, how are you going to figure out if they're equal, less than, greater than, or what's going on?
I would half like the 15 and then half that and see if the half of 15 is greater than the half of the 9.
Okay, that's one way to look at it. To reason, just be logical about it and reason, right? So you can go 15, and what's half of 15?
7.5.
Okay, and that's more or less than 7.5.
Mm-hmm. Yes.
So we know this is, we'll just go like this, that's more than half.
Yes.
Okay, what about the other side?
This would be 10, and then 10 will, 8 is less than 10.
Okay, so this one is less than half. So which one of these
would be greater?
Right. Okay. All right, so go ahead and put the symbol in there. So here's another way that we can check this, okay? What is 9 times 20? So what's 9 times 2?
2, 18.
18, and we put a 0 at the end of it, right? Okay. Now, so this is 180.
Yes.
What's 8 times 15? So think about 8 times 10.
Yes, 80.
80. And what's 8 times 5?
35?
40.
40.
Right? So we've got 40 plus the 80 makes this 120. Which one's larger, 180 or 120?
180.
So this is still, that's one way to check it, okay, by cross multiplying, okay? So now, let's get rid of this and work on the second problem. So go ahead and read this one for me.
Like 18 and 12?
18 to 12.
Yes, 18 to 12. And 54 to 36.
Okay, now here, the first number is larger on both of these.
Mhm.
So you want to rewrite them as a fraction?
Yes.
Okay. So in this case, the strategy you used the first time with looking at what's half of this and see if it is, that's not going to help us because these are both going to be bigger than half.
Yes.
Okay. So another way to look at this is by simplifying these numbers. So is there anything that you can think of that will go into 18 and 36?
36. Oh, I have
They're both even numbers, so what do we know will go into those?
2.
2.
Yes.
Right, but let's think of a larger number. Okay, is there anything bigger? Like what will go into 18, first of all? We know 1 will, we know 2 will.
And 3.
3.
Yes. 4. Wait, no.
4 won't.
No. 5.
No.
No.
Because 3 times what is 18?
3 times what is 18?
3 times 6?
Yes.
2 times what?
2 times 9.
9. Okay, and then we have 18. All right, so those are all the factors of 18. Let's take the biggest one, the largest one, 18. Can 18 go into 36?
Yes.
How many times? Only twice, right?
Yes.
18 and 18 is 36. So 18 goes in here once, and 18 goes in there how many times?
Twice.
Twice.
Yes.
Okay. So now,
Oh.
is there anything that will go into 12 and 54?
No, I don't think so.
What about, let's think about the factors of 12 like we did up here. List all the numbers that go into 12. Start with 1, right?
1 and 2. 6.
Right.
And 12.
Okay. 3 and 4 go in there also, right?
Oh, yeah.
Okay.
3 and 4. Oh.
So we can just put 3 and 4 at the end. So now we know all of these go into 12. Think about any of these numbers that will go into 54. We know 1 will. We know 2 will. 3, 4. Let's take the largest one, 12. 12, 24, 36, 48. We're not going to get another 12 on there, are we? No. So 12 is not going to work. So let's go to 6.
6, 12.
What's 6 times 10?
16.
60. So let's go 1 less. 6 times 9.
Yes. 6 times 9 is
So 6 times 9, you get
54.
54. So let's divide each of these by 6. Okay, so 6 goes in here how many times?
2.
Okay, so cross that out, make it a 2. 6 goes in there, we said 9 times.
Yes.
So now we have 1
Over 2.
over 2.
And 9 over 2. So this is greater.
But let's take a look. 18 to 12. Let's simplify this. Will 3 go into each of these?
3. Yes.
Will 6 go into each of these?
Yes.
Yeah, 3 over 2, right? Will 6 go into each of these? We just said they would, right?
Yes.
9 and 12. But if we have 9 and 12, okay, well, that's not going to be, that's if 3 went in. So we're doing this. So now let's divide each of these by 3. 3 over 2, right. So if this is 3 over 2, and that's 3 over 2, what is that?
Oh, equal.
There you go. All right. Anthony, got it done. And once again, a big thanks to all of the staff and students at Jefferson Middle School. We had a wonderful day while we were out there. Hey, if you'd like Do the Math to come out to your school and we can do a little math in your class, simply give us a call. The phone numbers are at the bottom of your screen periodically throughout the program. Karis, you did excellent work with Morgan right there, and it was just funny that she called in with a math homework problem that you happened to be working on. So two birds with one stone is that little saying right there. Right now we're going to take a moment and we're going to go back out live to Loudon Elementary and visit with Mary Lou.
We are back live at Loudon Elementary School, the ACES After School program, and I have another special guest with me. Why don't you introduce yourself?
My name is Makai, and I am a 6th grader.
Okay, Makai. What's your favorite thing at Loudon?
Math.
Yeah? And are you getting ready to get all excited to go on to junior high next year?
Yes.
Yeah? Play some football there?
Yeah.
Yeah? Okay. Well, since you love math so much, Makai, we have a math problem, don't we?
Yes.
And you are dealing with dividing fractions. Yes? Can you kind of help everybody out on how we need to solve this problem? There you go.
First, we had to make the mixed number into a improper fraction.
Okay, and how do we do that?
Multiply the 9 and the 2, and then add the 4.
Okay. So what does that equal?
22.
Okay. So 22 over?
Over 9.
Okay. So now we have 22 over 9, and we're going to bring down our division sign, right? Divided by? 1/3. Okay. So on this, again, we can never ever multiply with mixed numbers, can we? We always have to change them to fractions. So we can't multiply and we can't divide unless it's a fraction. So am I ready to divide? Or is there one more step?
No.
Yeah, there's one more step, right? Because we want to change this division to what?
To a multiplication.
Exactly. So we're going to keep this the same, 22 over 9. So let's write that down underneath it. And change our division to multiplication. And because, Makai, we did that, because we changed this, we have to change what follows. So we need to do the reciprocal of 1/3. What's the reciprocal of 1 over 3?
3 wholes.
Okay, or we can write it as 3 over 1. Yes? But you are correct with the 3 wholes. Now we're ready to multiply. Okay, go ahead and let's multiply this out. So we have 66 over 9, correct? So we can have this as an answer, or can we change that to a mixed number?
Yes.
Okay, while you're changing it to a mixed number over there, I'm going to kind of quickly talk about how we could simplify it first, so you don't have such big numbers, okay? Does 3 go into 9?
Yes.
Okay, can we cross that 3 out? Because 3 divided by 3 is?
1.
Okay, so let's put a 1. And 3 goes into 9 how many times?
3 times.
So let's cross that 9 out and make it a 3. So now let's look at this. We're going to get a different answer, aren't we? So put an equal sign here for me. What's 22 multiplied by 1?
22.
Okay. And what's 3 multiplied by 1?
3.
3. Makai, if I were to simplify this down, that's what you get. Okay, so what we did is we just took a step ahead. We simplified it within the problem first, any common numbers, and made it not so big, huh? So change that to a mixed number for me, okay? So while Makai's changing that to a mixed number, quickly for my 6th graders, because we have 6th and 5th graders here today, but our 6th graders are going to be doing this problem, and some of our 5th graders are going to try it. So 6th graders, let's go over real quick what you're doing. First of all, we have a mixed number, and we had to turn it into a what, everybody? Improper fraction by multiplying, okay, denominator times whole number, and then adding the numerator. And then we did a same change flip. So we kept the first number the same. We changed division to what? Multiplication. And we did the reciprocal of our divisor, and our reciprocal is just flipping that second number. Remember, we only flip the second number. We keep the first number the same. Okay, Makai, what did we get as a final answer?
7 1/3.
Very good. Now, Makai has a problem for all of you guys. You ready? All right, Makai, go ahead and write up your problem on the board for them. Use the red marker. Go ahead and use that red marker for us. You guys, pencils are ready? Yes? Okay. Write it big for them. So we have 4.5 divided by 4/6. Go for it. So Makai already worked the problem out and he has the answer. So Makai, you're going to be walking around and trying to see who gets it correct, okay? Do you want to take the red pin and put a star by anybody who gets it right? Okay. Let's go. Let's see what they're doing here. Let's see if they have it right. Over here, if you notice, he has 9/2. Is that correct for his first number? Does he have it right so far? Yeah?
Yes.
Yeah, 9/2, and he has multiplied by 4/6. What did he forget to do right here?
To flip it.
You forgot to flip it. 6/4, kiddo. Right, 6/4. There you go. All right, let's go over to this table, Makai, and see how they're doing over there. Oh, let's go back that way. Okay, ladies, how we doing over here? Yes? Oh, you're close. Keep going, keep going. So we have our 9/2 multiplied by 6/4. Okay, you're very close. Yeah. Well, is it just 6? Let's see. 9 times 6 is 54. Okay. Let's see what your answer is. I'm trying to see what we did here. So, can we do this? Can we divide, change that to a 1? Can we change that to a 3? So what's 9 times 3? 20, close, 27. And what's 1 times 4? Okay, now try that with that. Okay, guys, when we come back, Makai, we're going to have the correct answer. Well, real quick, give us what our correct answer is. What is it? Tell everybody.
6 3/4.
There you go. So we're going to let them finish up their problem, and then when we come back, we have another special guest for you. So back to you at the studio.
All right, we'll look forward to that, Mary Lou. Hey, you know what? We'd like to thank Karis for coming in this afternoon. You're not through working yet, but we'd also like to send you home with a delicious meal, courtesy of our friends at Johnny Rocket. So congratulations on that. And if you happen to remember, when you go there, I would like you to ask for Lydia.
Okay.
Okay, Lydia is the one that runs that store over there, that restaurant. And you let her know that you were on Do the Math, and you've heard that she makes a terrific shake.
Okay.
All right? All right. Hey, we do have phone tutors available until 5:30. Just a reminder, you phone in today and tomorrow, you'll get yourself 2 tickets to Holiday Lights at Com. Right now, we'll go back to the phones. Fernando, how are you today?
Good.
And you're a 6th grade student, correct?
Yes.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Okay. My problem is 1,840.5072 divided by 23.56.
Okay, can you tell me the number one more time? It's 1,840.50. 0.5072. Okay, great. Do you know how to do this problem, or do you need me to walk you through it?
Actually, it's 23.56.
23.56.
0.56. Got it. Thank you very much. Perfect. Okay, do you know how to do the problem, or do you want me to help you?
Can you help me, please?
Okay, so on the show just a few minutes ago, we were multiplying to be able to get this out a little bit to make it a whole number, but I'm going to show you a different way. So I'm just going to be putting them in the normal way that I teach it. So we're just going to line it up like this. We're 23.56, and I always say goes on the outside of the house just because it's a little easier. And then on the inside of the house, we're going to put 1840.5072. Okay? And the way I teach it, which is just a little bit different, I always try to move over the decimal to make the outside of the house a whole number, which is what she did earlier. So we're going to move the decimal over twice. We'll move it over on the outside and then again on the inside. So now we have a whole number on the outside. Okay? Okay. So now we're going to take the 2356 and we're going to divide it into 18405. Okay? Okay, can you give me a little bit of help on that, or do you want me just to try to work it out so you can watch? Which would you prefer?
For you to work it out and then I watch.
Okay, so we lost it. Let me see if I can, there we go. I found it. No worries, we're all good. Okay, so let's try to do the 2356. And we're just going to see how much we can get into for this is the number that we're trying, the 18405.
And to help you out because of time,
yes,
we're going to give you a head start. We're going to go 2356, and I'm going to times that by 7.
Okay.
So that is going to give you 16492.
16492, okay.
So go ahead and you guys can subtract that, see where you're at, and go from there.
So we're going to subtract that. So 2 minus 5 is 3. 9 minus 0 doesn't work. So we're going to do that. 9 minus 10 is 1. 4 minus 3 does not work. So we'll do that. Move it over to the 7. 4 minus 13 is 9. 6 minus 7 is 1. So now we have 1913, and we are bringing down the 0. And since 16492 was 7, I'm going to go up a couple more. Let's say 1. So we'll do 2356 times 8. And we have, let's see.
Well, hold on. I'll just help you out here. 18848.
18848. Fernando, are you kind of with me?
Yeah.
Okay, so then we're going to subtract that, so that doesn't go. We have to continue, so that's 2. 4 goes into 12, 8, 9, 10, 11, 12, 8. And we still have to carry. Let's see, that's a 8, 9, 10, it would be 2.
Well, hold on, because you're going to borrow from the 9. That's going to be an 11, so that'll be 3 underneath.
Yeah. Woohoo! See?
And that 9 would have become an 8.
Yeah. So it's 1392. Like that? Okay. So we'd be at 1392. Now we have to pull down the 7?
Well.
No? Did we mess up?
It's just going to be 282 because the 12 minus 4 would be 8.
No, I just like it.
Right, so get rid of that. Just put 282.
Got it. There we go. Okay. Now we have to bring down the 7. Is that good now?
Yes.
Okay, so we have 2356. Now we have 2827. How many times do you think it would go in? Maybe 1?
That's going to do it because otherwise you'd be over. So what we're going to do is we're going to let you guys keep working on that.
Okay.
All right. So Fernando, what we're going to do is we're going to keep working on that problem, and we will get back and make sure that you've got the correct answer. And what we're going to do right now is we're going to go for our last time live out to Loudon Elementary and check in with Mary Lou and the gang.
Thanks, Mike. We are back here at Loudon Elementary School, the ACES After School program, and I have another special guest.
Alyssa, and I'm in 6th grade.
All right, Alyssa, you ready for junior high next year?
No.
Yeah, no. Enjoy your time here, huh? Okay, so we have a math problem behind us, right? And we were doing fractions, dividing fractions. But we're going to step back a minute to subtracting fractions, okay? So we want to do a comparison about the difference between adding and subtracting fractions versus multiplying and dividing. So here's our first problem. We have 4 7/8 subtract from 3 1/2. What do we have to do before we can start this? What must our denominators be?
Our denominators must be equal.
Yeah, they got to be equal, right? So does 2 go into 8?
Yes.
Okay,
4 times.
very good. So we're going to keep 8 as our denominator. Is this already good to go? Can I leave that as 7 eighths? Yeah, we're going to leave that as 7 eighths. And this, you said 4 times, right? Okay, so put the number here. What must that be? What's the equivalent? Okay, so now we're ready to subtract, right? So, Alyssa, go ahead and subtract. What's 7 minus 4?
3.
3 over what? And then what about our whole numbers? Do we need to subtract our whole numbers?
Yes.
Okay, what's 4 minus 3?
1.
Okay, so what's our final answer for this?
Our final answer is 1 whole and 3 eighths.
Okay, so when we're adding and subtracting, the most important thing is we have to have common denominators, right? And that takes a lot of work. And a lot of students don't normally like it because there's so much work, huh? So let's go over here to our dividing problem. So now we have a dividing problem, but do we need to worry about a common denominator here?
No.
No, we don't. Or here we do, right? But here we really don't. So we're keeping 5 eighths the same, right? So let's bring that down. Here, I'll give you another. You could use that one. So let's bring down 5 eighths. But we're going to change the division to a
multiplication.
Very good, multiplication. And I cannot multiply it by 2 and 7/12. So what do we have to change this to first?
So 2 times 12. So you have to multiply the whole by the denominator and add the numerator.
Very good. So 2 times 12 is?
24.
Let's write it over here as 24, right? Plus 7. What's 24 plus 7?
24 plus 7. That would be 31.
Okay, so we have 31 over what?
31 over 12.
Okay, so what did we say last time? 31 over 12, we have to do the what? We have to do the?
We have to flip it.
Flip it. So let's flip that to 12 over 31. Okay, before we multiply, you got big numbers, don't you? You don't want to multiply by these big numbers, do you? Because I know I don't want to multiply by them. Ask yourself, does 8 go into 12? Or is there a common number with 8 and 12?
Oh, yes.
What number?
4.
Yes. What's 8 divided by 4?
2.
Cross that off and make it a 2. What's 12 divided by 4?
3.
Okay, cross off the 12 and make it a 3. There you go. Now you're ready to multiply, so we don't have to do all of that simplifying. What's 5 multiplied by 3?
15.
Okay. And 2 multiplied by 31.
2 multiplied by 31.
Think about it. What's 2 times 1?
That would be 62.
Perfect. Put it there. And I don't think we can simplify that anymore. Because you simplified it in the problem, boom, you got your answer right away. Good job. And again, remember the difference between adding and subtracting and multiplying and dividing. What do we have to find here?
The common denominator.
And then here we always have to make sure that these mixed numbers are a fraction, right? And we always do the flip it. Good job, good job. And I want to thank everybody here at Loudon today, and all of you guys here today. Thank you for helping us out. It has been a pleasure working over here today. And that is all from Loudon. And again, thank you to the ACES After School Program for allowing us to come here. So we're going to send it back to you at the studio.
All right, thanks for that. Quickly, what we're going to do is we're going to show the answer to Fernando's problem, so make sure that Fernando's got that, and we will contact him to verify that. So it is 78.12. Karis has been working great today, and right now we need to find out who is the lucky recipient of 2 tickets to a CSUB athletics event of their choice, and it is
Alyssa from Loudon.
There you go. So Alyssa, congratulations. You've got yourself 2 tickets to any CSUB athletic event. Congratulations on that. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.